Hi, I'm Mrs. Sloan, and this is a video for my honors biology students. This is part 2 in our chapter on glands and hormones. In part 1, we already discussed the function of hormones. We talked about homeostasis and feedback mechanisms. We also talked about peptide hormones versus protein hormones, and we focused on the connection between the hypothalamus and the pituitary gland. So if you need to watch part 1, please go watch part 1 because we're going to continue on in our series. Now, down in the descriptor of this video here on YouTube, you will see the notes that my students use. Column 1 is the scaffolding. I'll help you fill that in. Column 2, I encourage my students to put in pictures to help them with the learning. So we are on, in our notes, 20.3, the thyroid and the parathyroid gland. And so what we're going to do is talk about that and these other glands and make sure that we understand their functions. All right. So the thyroid gland, first thing you need to know is on top of the thyroid is I need a pointer. Sorry. Hang on a minute. I'm all over the place. Let me try again. Turn on the pointer. Okay. On top of the thyroid gland, you have 2 on each side, which would be the parathyroid gland. All right. So the thyroid gland, its chief job is metabolism. How fast your metabolism. So you have anabolic reactions, which require energy and are about building. You have catabolic reactions, which are breaking things down, like cellular respiration. And it's a balance between both of those enzyme-mediated reactions that gives you your metabolism. Now, the thyroid gland also secretes another, and there's actually a couple hormones involved with that. We're just going to call it thyroid hormone. Calcitonin is another hormone secreted by your thyroid gland. And what it does is you have different levels you could have of calcium in your blood. And what calcitonin does is it lowers the blood calcium in order to maintain homeostasis. So the way I teach this to my students is you better tone it down now. So calcitone it down now so it brings down the calcium levels. So on your notes, you have number 1, hormones, thyroid hormone, multiple targets. It regulates metabolism. Now, in order to build thyroid hormone, it requires iodine. Put a pin in that. I'm going to come back to that later. Calcitonin, you have that one. It lowers blood calcium levels. Now, your parathyroid gland, if you jump to the bottom of that box, parathyroid, this is an antagonistic hormone because whereas calcitonin lowers blood calcium, the parathyroid hormone raises blood calcium levels and it lowers blood phosphate levels. So I just want you to know that these are antagonistic, calcitonin and parathyroid hormone. So on your notes, parathyroid hormone raises blood calcium and it's contrary to calcitonin. Now, earlier we talked about positive and negative feedback mechanisms. Remember, your hypothalamus is an important part of your nervous system with regards to homeostasis because it regulates your master gland, your pituitary gland that we discussed last video. And there are hormones from the pituitary gland that affect multiple targets within your body, and one of those targets is your thyroid gland. So this, I'm going to show you an example of negative feedback. All right. So remember what I talked to you about, that the posterior pituitary, see how it's in dark brown all the way up to the hypothalamus? The posterior pituitary descended from the hypothalamus, and there is a direct connection with neurosecretory cells extending down through the stalk all the way into the posterior pituitary. And the hypothalamus actually makes the hormones that the posterior pituitary secretes, oxytocin and ADH. Now, remember, your anterior pituitary grew up and out of your mouth. It kind of jumped up here and grabbed onto the stalk. So there's not a direct connection. So remember, your hypothalamus can get as far as the stalk with its neurosecretory cells, and it puts in releasing hormones. These are carried by the blood to the anterior pituitary, a place where you have double capillaries, right? The first one in the stalk, the second one in the anterior pituitary. These releasing hormones then trigger the anterior pituitary to secrete stimulating hormones, which then will go and stimulate that target gland. As that hormone increases, it'll exert negative feedback on both the hypothalamus and the pituitary gland. So here are those hormones identified, right? Thyroid releasing hormones is made by the hypothalamus and put in the stalk here at the anterior pituitary. This then makes the anterior pituitary secrete thyroid stimulating hormone, which is then carried by the blood to the thyroid gland, so it'll secrete thyroid hormone. This goes back and has negative feedback when the levels are high enough on both the hypothalamus and the pituitary. So on your notes, example of negative feedback, hypothalamus secretes thyroid releasing hormone, and then B, this stimulates the anterior pituitary to release thyroid stimulating hormone, which then stimulates the thyroid gland to secrete thyroid hormone, and that gives negative feedback to both the hypothalamus and the pituitary gland. So that's just one example of that. Now, if you recall, I told you that this thyroid hormone produced by the thyroid gland requires iodine. If you don't have enough iodine, you won't make enough thyroid hormone, and therefore you cannot do negative feedback on the hypothalamus and the pituitary. So when it doesn't happen, it's like the hypothalamus is telling what the pituitary to do, pituitary is telling the thyroid what to do, but it's not doing it. So then the hypothalamus starts yelling at the pituitary starts yelling at the thyroid gland, make some thyroid hormone. This can cause the thyroid gland, if it doesn't have enough iodine, it starts to swell the thyroid gland, and this is called a goiter. This is an enlarged thyroid gland. Why? Because of lack of iodine, and it can't make it, so the hypothalamus is still signaling the pituitary, which is signaling the thyroid gland. Now, here's some other pictures, because I know you love them, of goiter. This is like, wow, look here and here and here. You do not see too many examples of goiter anymore. And the reason is, think about your salt. If you go look at it, it is called iodized salt. Salt is put on so many of our foods. That's how we also get our iodine too, because it's part of the salt you shake on your food. So disorders, you have everything for that. It's hyposecretion, which is too low, of thyroid hormone due to a lack of iodine, which causes the thyroid gland to swell. Now, in mini-me, meaning I'm not going to hold you accountable for it, there's something called cretinism, and this is when you have hypothyroidism since birth. So these 4 gentlemen are all the same age, but because they didn't have a high enough metabolism, it stunted their growth and affected their mental development. When you have hypothyroidism in an adult, like maybe because there's cancer of the thyroid and it has to be removed, this also lowers their metabolism. So this is what has happened here to this gentleman, and this is why they would have to take a thyroid medicine. All right. Now, hyperthyroidism is called Graves' disease, and this is when the thyroid gland is over enlarged or exaggerated, and it kind of makes the eyes bulge out. I had the opportunity to talk to somebody who has hyperthyroidism, and occasionally what has to happen is his eyes are actually removed from his socket. The connective tissue that's building up behind the eyes, pushing them out, has to be scraped out and kind of set back into the socket. So that's pretty scary. That's hyperthyroidism. All right. Now, your next one is the adrenal glands. On your adrenal glands, the introduction, they sit on top of your kidneys. Now, your adrenal glands, just like you could have in your cerebrum, right? You have your cerebral cortex, then you have your medulla oblongata, the outer and the inner. Same thing here for your adrenal gland. Now, the cortex is all about sustained response to stress. And these 3 hormones right here are all steroid hormones, just like the hormones that come from testes and ovaries. Your adrenal medulla is epinephrine and norepinephrine. This is all about fight or flight. So on your notes, the adrenal medulla is controlled by the ANS. Remember what that means? Autonomic nervous system, right? It is a short-term response to stress. Adrenaline and epinephrine is fight or flight, and noradrenaline or norepinephrine is with anger. Okay, with anger. This might be, let's say, mom, their child runs out in the street to chase a ball and they're scared and go get their kid, and then they start yelling at their kid. That's the anger that comes with the fear. Okay, that's what noradrenaline is. Now, your adrenal cortex, this outer part, this is controlled by adrenal corticotropic hormone secreted by the anterior pituitary, and it is a long-term response to stress. You don't need to memorize these. I gave them to you what they do, but you don't need to memorize them. Glucocorticoids, you can hear the word glucose in that, and cortisol, that's a steroid hormone, so that does have to do with sugar. Mineral corticoids has to do with water balance, like aldosterone, and then sex hormones. These are all steroid hormones, so I wanted to remind you, steroid hormones go right through the phospholipid bilayer. They bind to a receptor inside the cell and affect the DNA directly and protein synthesis, right? So to give you an example, if you have a quiz, that might make you start secreting epinephrine and norepinephrine if you're stressed about this quiz. Sustained stress response, that's like the pressure of a whole semester of school. All right, moving on. And this one we've talked about a little bit already with the pancreas and insulin and glucagon, but the pancreas really plays two roles. It is both an exocrine gland for digestion, secreting enzymes like pancreatic amylase to help digest starch and lipase to help digest fats, but it is an endocrine gland because it secretes directly into the blood as well. And there are little islands of cells called islets of Langerhans that will be secreting your insulin and glucagon. You have alpha and beta cells within there. So it's both an exocrine and an endocrine gland. And I gave you that already on your notes. And remember from what we talked about before, what insulin will do is it'll lower your blood glucose level in order to maintain homeostasis. And the antagonistic hormone is glucagon, and glucagon will raise blood glucose levels by getting your liver to release some glycogen as glucose. Whereas insulin can maybe help your muscles to take up some of that glucose, or you will store that glucose as fat in order to get your blood level just right. Okay, and let's see. Oh, some disorders of that. So there's type 1 diabetes, and this is usually due to an autoimmune disease because you have an insufficient supply of insulin because your immune system has attacked those cells that make insulin. So type 1 do not produce enough insulin, and that would be a hyposecretion. Type 2 diabetes or maturity onset, this is insulin resistance. And let me explain this to you. Right, pretty soon, if every time your mother, your father, or somebody was angry at you, they yelled at you, pretty soon yelling wouldn't startle you anymore, right? Because you're like, they're always yelling. They would have to really yell super, super loud to make you respond because they're always yelling. If you always have blood sugar in your body and you're always secreting insulin, your cells start to ignore it because they think it's just the normal course of business. So what happens is you have too much glucose in your blood supply, and that can cause other problems. So type 2, body tissues do not respond to insulin. Body tissues do not respond to insulin. Okay, next, your other endocrine glands, we're going to start with your testes and your ovaries. Both of them release steroid hormones that affects gamete development, your development as a male or female in the binary world, hair growth, and functions of the sex organs. Your ovaries, it's not just the typical things that we think about like uterus and breast tissues for the effect of estrogen. It also affects your heart, your liver, your brain, and your bone development. So ovaries secrete estrogen and progesterone. It impacts fat development, your uterine cycle, your bone density are all impacted by that. All right. The testes secrete testosterone. It has to do with muscular strength, vocal cords, acne, body odor, baldness. These are all things associated with testosterone. If you have a lot of testosterone and you are a young man, you'll probably be having a little bit of acne because you have so much testosterone. That is a result of that. Now, Some people are tempted to take testosterone in order to build muscle, which you will if you have artificial high levels of testosterone, but that will also cause negative feedback. It will cause your testes to shrink because your brain will start to say, there's too much testosterone in here, stop testes, because you're giving it to yourself artificially. Your nipples will start to become sore and enlarged. You will start to have a little bit of breast development if you continue to do that, even in males. So I would not recommend that. All right. So on your notes, I think I gave you everything for that. All right. Another gland, your thymus gland. We talked about the thymus gland in the immune system. Remember, when you are younger, it is larger because that's when your T cells are learning self from non-self. And the thymus secretes a hormone called thymosins that aid in the differentiation of your T cells. So on your notes, hormone is thymosin, gland above the heart. It's larger in children, stimulates T cell maturation. T cell maturation. All right. Your pineal gland is located here. This is your thalamus right here. It's towards the back of it. Here is your pineal gland. And this establishes our circadian rhythms. When we want to wake up normally, when we want to go to bed. We notice this if we ever go through time changes, especially if the clock jumps ahead. It's really hard to get up in the morning because we have this set time. Now, one thing that affects the pineal gland, okay, for instance, if in the middle of the night, okay, you will secrete melatonin from your pineal gland. But if, let's say, you wake up in the middle of the night and you turn on a light to go to the bathroom, that bright light will shut down your pineal gland. It's like your third eye. It'll shut down the melatonin secretion and it drops, and it can be harder then for you to get back to sleep, and you'll have less levels of melatonin. In the winter, when there's less light, you'll have more. When there's less light, you'll have more melatonin. In the summer, when there is less light, you will have less melatonin. And this is how some animals know when to reproduce, is by the levels of melatonin. So on your pineal gland, the hormone is melatonin. The gland is in the brain. It is your circadian rhythms. If you want to know how to spell that, let me go back. It's right here. Circadian rhythms, daily behaviors, and it affects your reproductive organs. All right. And then next, I want to transfer and talk about some other hormones from places you wouldn't think of as being glands. All right. So for instance, your adipose tissue, okay, will secrete leptin. So leptin is produced by your fat tissues, and this tells you you are full, stop eating. Sometimes we eat so fast because we're starving, okay? We eat so fast that this is when much later, after we're like, oh, I don't feel good, I ate too much. If we would eat a little bit slower, it would allow our endocrine system to tell us, hey, you're full, it's time to stop eating. So I say leap away from the table. So leptin. Okay, so on that one, it's produced by fat tissues and it gives you the sense of fullness. All right, growth factors. Growth factors can be secreted by multiple different tissues, these growth hormones. And when that happens, it's going to affect all different parts of your body. And some people choose to abuse it. This is somebody who is taking a growth factor in order to have larger muscles. I'm going to tell you that's not attractive for most women that I have talked to. Okay, released by many tissues, and it stimulates cell division, but it's released by many different tissues. Okay, EPO, this is a hormone secreted by our kidneys, and it's to increase our red blood cell production. So EPO secreted by kidneys to stimulate red blood cell formation in our bone marrow. All right. And then prostaglandins. Prostaglandins act locally, just around the neighboring cells. They can promote the inflammatory response. They can inhibit it. They can reduce gastric secretions, lower blood pressure, uterine muscle contractions. Most people, when you're taking aspirin, you're doing it to inhibit prostaglandins. So, because it counteracts that. And so the only part in the notes you need to know is that it acts locally. All right. And then the next topic I want to talk about is pheromones. So pheromones, let me go one more slide here. Pheromones are are a chemical signal that acts between two different organisms, whereas hormones act between two different body parts within our body. Pheromones are chemicals we release that impact another organism. So defined as chemical signals that act between individuals. And these are really important in a lot of different species, right? It can give a signal of fear. It can be a signal of come hither, I'm ready to reproduce, right? Many different purposes of pheromones could mark a territory. So there are a couple interesting examples about pheromones and humans. One is women prefer men that have a particular smell. And let me talk to you about this. They did this experiment where they had men stand up. They were like objectified, like you would like a beauty pageant, and women picked who they thought was attractive based on just looks. Okay, they had those men wear a t-shirt for a day or so. Then they had them take the t-shirts off. They put them in Ziploc bags, marked them. No, just the experimenters knew which t-shirt belonged to which gentleman. Then they had women go and smell the bags and rank them on what they were most attracted to by smell. And it did not always match visually who they were attracted to. And what it came to is, remember our immune system and those MHCs, MHC1s, and MHC2s? Women preferred men, it turns out, who had different MHCs than themselves. So women prefer men who have different MHC molecules than themselves, right? That would give your offspring a better chance because you would have greater variety. So that's why maybe you think somebody's great, you go on a date and then you smell them and you're like, yeah, no. Or vice versa. Okay. Axillary secretions. These can be by men, they can be by women. And axillary secretions may affect potentially, maybe, the menstrual cycles of other women. So let's say you have a mom and 3 sisters who live in that house, or you're at a dorm, a female dorm. What can happen is you can have kind of an alpha female draw the other females onto her menstrual cycle. Some people say that's true. Some science backs that up. Other science say maybe no, but it is a possibility. All right. And then one of my favorites, because I think it's protective, I guess, the tears of women have been known to decrease the sex drive and the levels of testosterone in men. Now, why would that be adaptive? Because men shouldn't make women cry. So, number 3, women's tears lower male testosterone and sex drive. All right. And that brings us to the end. And if you are one of my students, I can't move this. Okay, let me try this. Okay. And if you are one of my students, I'll see you in class.